Every year, the Bundeswehr spends billions of euros on procuring new weapon systems, ammunition, equipment, and services. But before a new weapon system can be deployed, it must first demonstrate its performance and safety. Overseeing this critical task is the German Federal Office of Bundeswehr Equipment, Information Technology, and In-Service Support, known as BAAINBw. BAAINBw, with its 6,500 personnel, operates as part of the Bundeswehr's organizational area for equipment, information technology, and in-service support. In total, around 11,000 women and men work to ensure that the troops are equipped in the best possible way as directed by policymakers. To achieve this, each year, thousands of tests, studies, and research projects are carried out and evaluated at 116 locations across Germany and the USA.
Hands up! Drop the knife! Drop the knife! Ich auch.
The Münster South Military Training Area in the north of Germany. What might look like an open-air puppet theater at first glance is an important element of the first all-digital shooting range of the future. Digital, flexible, mobile, variable, and capable of learning. According to the engineers and technicians at the Military Technical Testing Center 91 in Meppen, the stiff cardboard comrade is slated to retire soon. The shooting range of the future will focus on smart targets. And so will the computer-aided evaluation.
The falling target is constantly visible and it stays in the same place. The mobile target moves freely through the terrain, depending on what the instructors have in mind. All kinds of scenarios are possible. You couldn't do that with the old technology.
The new technology turns the firing range into an interactive battlefield for the soldiers, who will receive the best possible preparation for the realities of live combat. Just like these soldiers from the military police, who are among the first to try out the Future Firing Range 4.0. The Feldjäger are the military police of the Bundeswehr.
Smart targets are ideal for our training. They simulate and execute a natural sequence of movements. So they're a great tool for the troops. This was the first time we were able to work with actual targets.
The four-wheeled opponents behave almost like real soldiers. They move around the battlefield, make clever use of the terrain, and seek out natural and artificial cover.
The system can attack by reacting to fire. It can seek cover autonomously. It also has what's referred to as a muzzle flash. It has acoustic playback, and that can be implemented in the simulation.
Target.
Ja, ins Ziel.
Fire. Between the blue house and the tree.
In contrast to conventional falling targets, there's nothing the soldiers can plan for in advance. In the future, instructors will be able to use the system to write a customized script for firearms training. Depending on the specific skill to be trained, and unlike the falling target, not every hit is immediately fatal. Just as in a fierce firefight, where wounded adversaries can continue to return fire.
There's a sensor system inside the dummy. This sensor system detects fire. It has two hit zones, a lethal hit zone in the middle and two zones on the edges. These can be configured, and the target's behavior can be adjusted accordingly. So maybe a side hit would mean that the dummy can only move at a reduced speed.
This is made possible by the digital control center stored on a laptop. It contains all the important data for the shooting range and the functions of the smart targets. In the future, trainers will become directors, judges, and instructors in real time. Depending on the terrain, smart targets can reach speeds of up to 18 kilometers per hour. No fully equipped soldier is faster than that. The training can even include enemy vehicles, such as this pickup, which can travel at almost 50 kilometers per hour.
It would be helpful if we could get these targets as quickly as possible, because then we can make sure that our training is as close as possible to a real deployment scenario.
But to accomplish this, the control center first has to be fed with important data from the respective shooting range. What's known as a LiDAR laser, which has been integrated into the smart targets, helps with this. It scans the shooting range, recognizes obstacles, and generates a 2D map of the terrain. This permits extremely realistic reenactments of even hostage situations, where kidnapper and victim are moving close together. After decades of the falling target, the smart target will revolutionize firearms training. Bavaria, Feilenmoos, near Manching. A training area of the Military Technical Testing Center 61 is located here. This is where practically everything that has to do with flying in the Bundeswehr is tested. This includes the Tiger combat helicopter, which is equipped with a variety of different weapons and self-defense systems. This test is designed to evaluate hot rearming, safe reloading while the rotor is running.
My main focus in this test is on the takeoff and landing phase because they're very challenging, especially at night. And then on the ground, the crew's focus is on making sure the loading crew moves around the helicopter as safely as possible.
The engineers, technicians, and test pilots at Training Center 61 are tasked with determining whether the weapon stations can be reloaded safely with the helicopter's main and tail rotors turning. This procedure, known as hot rearming, reduces the time between landing and takeoff during combat. This is also comparable to the quick tire change and refueling in the pit stop lane in a Formula One race. Everyone has to know his or her job and where they are allowed to be. This is precisely the challenge with this rearming. With the enormous helicopter noise, its engines howling, and its main rotor kicking up a mini-storm all around.
The difference between cold and hot is that the rotor is turning when the loading process is hot. This has a significant impact on communication, which is limited due to the rotor noise and the downdraft. The rotor also generates static electricity as it turns. In a worst-case scenario, this could accidentally trigger the weapons.
That can't be allowed to happen here or in everyday flight operations. Once the flight tests are completed, they will benefit the Tiger pilots and ground crews with safe procedures and proven sequencing that will minimize the risks involved. But to get there, the test pilots and engineers have to break new ground. Even if all risk factors have been theoretically calculated, analyzed, and war-gamed in advance, unexpected situations are a part of this business.
There's always a residual risk, of course, especially during test flights when you're doing things for the first time or testing things for the first time. That's why test flights are not carried out by just anyone, but only by specially trained personnel like those here at Technical Center 61.
The Tiger has 4 weapons stations under its stubby wings, and these can be equipped with a mix of weapons. These include unguided rockets, a heavy machine gun, guided anti-tank missiles, and Stinger air-to-air missiles that can be used to combat enemy helicopters and aircraft. In an emergency, these have to be reloaded simultaneously by a maintenance crew. So hot rearming is not just about perfecting the safe loading and unloading of the various weapons on the Tiger from a purely technical point of view.
With this procedure, the most important thing for me is actually to optimize communication between the ground crew and the flight crew. As a pilot, you always want to know what's going on around the helicopter. Especially at night, when visibility is limited, it's very important for me to know who's working where.
Later on, the test results will form the basis for regulations and procedures that helicopters and maintenance crews will have to follow during routine flight operations to prevent accidental firing. Meppen, in the Emsland region of Lower Saxony, not far from the German-Dutch border. Military Technical Testing Center 91 is located here. Practically everything that has to do with ammunition, weapons, and protection is tested and approved here for its suitability for deployment. Among other things, the testing facility has special material firing stands for this purpose. Today, the test crew is going to test the bullet resistance of bulletproof glass. Before a company is granted permission to use this special glass for the windshields of armored vehicles, of, for example, the Bundeswehr, it has to be tested and certified for bullet resistance. High-quality special glass like this does not offer 100% protection, but it must at least be able to withstand the first hit.
It's just several layers of a tear-resistant plastic film. It's designed to stop the fragments when the glass is hit.
The decisive factors here are the caliber and the battle range. With the firing range in Meppen limited to 100 meters, the different battle ranges are simply simulated using custom ammunition. The specially trained ammunition specialists in the arsenal at the testing facility are responsible for these so-called loads. The caliber this time is the 20mm round, which will be individually prepared. The 20mm round is fired, for example, from the board cannon of the German Marder armored vehicle. In this case, to prepare for the special firing test, the projectile is separated from the ready-to-use munition supplied by the industry. This process, known in munitions technology as separation, involves mechanically detaching the projectile from its casing. This is accomplished by first clamping the projectile and then pulling it out of the cartridge casing using hydraulic force. Then, the propellant powder within the casing can be removed. When a live round is fired, the propellant powder is ignited by striking the primer in the cartridge base. This creates a gas pressure in the tube that accelerates the projectile. The propellant powder for the ballistics test is specially manufactured. It's highly sensitive and literally a fire hazard. This is why everyone working on munitions must wear special anti-static clothing. The humidity in the workrooms is also artificially regulated and constantly monitored.
If the humidity here is not above 50%, the powder could ignite itself through friction. And what does that mean? That the risk of burns is pretty high here.
Once the previously specified quantity of powder in the propellant charge has been precisely weighed, the new cartridge can be loaded. This also includes a foam pad and a precisely defined quantity of kapok, a fiber material. Kapok is made using the fine fibers of the kapok tree. Both prevent the formation of cavities in the cartridge. This ensures defined and even combustion of the propellant powder in the cartridge, because later in the test, the projectile has to work exactly as specified by the Bundeswehr's test specifications for impact velocity. The amount of powder and what is referred to as standard shrapnel ensure that the desired battle range can be simulated. The cylindrical standard shrapnel is a NATO-wide test projectile used to simulate artillery shrapnel. The shrapnel weighs around 54 grams and is around 24 millimeters long. Each loaded cartridge is always intended for a very specific firing test.
Right now, we're making the 20x139 cartridge with standard shrapnel. That's actually a one-off, so it's not mass-produced.
Safely packed in wooden crates, the specially loaded cartridges are transported a few hundred meters by van to the material firing stand. For safety reasons, the shot channel of the 100-meter-long facility is surrounded by a 4-meter-high protective wall. There, the armorers have already prepared the weapon, which has special properties for such tests.
Das ist unser Munitionsprüfgerät.
This is our munitions testing device, and by changing the barrel, we can also change the caliber. It is fired electrically, so there's no one behind the gun and we can shoot safely.
Line active.
Do you have the all clear?
We have all clear for one shot.
The munitions testing device is a measuring weapon without a magazine that is used in ballistic testing. Hence, just one cartridge at a time can be loaded and fired. The device can be pushed to the exact firing position using a trolley that can be moved on rails along the firing line. The weapon is fixed in place there. The armorers then aim at the center of the bulletproof glass using the rifle scope. For safety reasons, everyone must remain in the safety and control rooms during firing.
Weapon ready.
We have all clear for one shot. Weapon fully loaded. On my command, 3, 2, 1, fire. We hit the center of the glass pane with the speed and the distance required for the test. The bulletproof glass has passed the test so far. You can see a nice large bulge. So far, there are no chips. From our point of view, the glass is now past the test.
A few kilometers away from the firing range, at the vast testing grounds of Technical Center 91. This is the future Enforcer light-guided missile. The name is somewhat warlike. But this first test shot is not about the power of the weapon, which has a sophisticated seeker head. In place of the high-explosive fragmentation warhead, the test missile is fitted with a camera-supported telemetry head. In a certain way, the telemetry head acts as a flight recorder and records important parameters during testing. This is because, under joint development by the manufacturer and the Bundeswehr, the first priority is to collect important data on the aerodynamic properties and the target acquisition system. Incidentally, in Bundeswehr German, the completely new infantry weapon is not referred to as an enforcer, but as the Wirkmittel, or Weapon 1800+. 1800 stands for the operating range, at least 1,800 meters. Later on, it should be possible to be fired effortlessly by a single soldier. Lots of test shots are due to be taken between now and then. But this is also about the power of the weapon. In other words, the performance of the warhead. As a light and fast infantry weapon, the Enforcer is primarily intended to destroy unarmored and light armored targets. To test this, the warhead is triggered in different situations and its fragmentation effect is then evaluated. The test engineers use a blast enclosure referred to as a Sprenggarten, blast garden, framed in metal plates that can be penetrated by the shrapnel.
5, 4, 3, 2, 1, fire.
The different thicknesses of the metal plates can then be used to determine the penetrating power of the shrapnel. The fragmentation pattern is also visible on the metal plates. This allows the testers to determine not only the number of pieces of shrapnel, but also their dispersion. This information is important when assessing the effect and quality of the warheads.
Of course, we tested several warheads against the same target. And we test not just the function and penetration performance, but of course the uniformity of warhead performance as well. So we can also say that the company has consistently delivered the same level of quality.
Sometimes, warheads perform significantly better than the specifications set by the Bundeswehr in advance for these new systems. After all, in a combat situation, soldiers must be able to count on a weapon to be effective and reliable.
We conducted 2 tests, one at a height of 5 meters and one at a height of 3 meters, to see how the fragmentation patterns differ at different heights. The angle of the warhead matched the trajectory angle of the missile. In other words, the trajectory angle of the missile was simulated here, and then the warhead was statically detonated. And we see a nice fragmentation pattern here, actually more than we expected.
The seeker head, with its optical sensors, is responsible for ensuring that the warhead hits the target accurately. This highly sensitive sensor technology can also be tested. Here in this dome, located in Greding, Bavaria at the Technical Center 81. The interior is crammed with electronics, simulation technology, and computer systems. The whole thing looks like a giant gaming console. Except the interest here is in lethal weapons technology. Engineers can use high-speed cameras to scrutinize every single phase of the live test firing on the training grounds. From igniting the propulsion, catapulting the guided missile out of its rectangular launch box, unfolding the fins and the flight characteristics, through to the impact at the target. However, what they cannot check during these rigorous tests is the real key to the success of such a fire-and-forget weapon. Once the soldier has aligned the optics with the target and activated the seeker head, the guided missile searches for the target all by itself after firing. At that point, the shooter can no longer intervene. The simulation dome can be used to see whether the autonomous target control systems are working. A guided missile is comparable to the human body. The eyes, nervous system, brain, and legs all have to work together to reach the destination.
To fully simulate this, we not only try to find out how image processing works, but also whether image processing sends the right signals to the autopilot, which then takes over control of the missile. And since we're not shooting live here, of course, we have a 3-axis turntable that receives the signals, specifically the steering, and simulates the missile. Okay, I'm moving now. I'm moving towards my target. And based on the movement and the data that is stored, we can track, did it behave as we expected to?
Back at Military Technical Testing Center 91. Not just since the Russian war of aggression against Ukraine and the massive use of various reconnaissance and attack drones has the fight against such systems been high on the military's list of priorities. The arms industry and the military are concentrating on a new form of engagement, especially for ships, the precision-targeted, high-energy laser weapon. The testing facility has set up a new laser technology unit specifically for this purpose and created testing grounds for laser weapons.
Laser position is set. 3, 2, 1, laser on.
Laser systems like these can be used in a ground-based system or in a vehicle. For instance, scouting missions where you can use an invisible laser to silently cut wires, cut antenna masts, weld doors shut, or things like that. You can imagine lots of things that can be done with such systems. Ultimately, it's a laser that can be used to process materials. You can shoot at plastics or at metals.
Industrial lasers like these, which are also used for testing here in Meppen, are nothing new. They've been used in industrial production for years. To cut steel plates with millimeter precision, for example. It always begins with an energy source, in this case, electricity. The laser process generates a laser beam of the highest quality in a thin beam that can be focused at great distances in order to deliver optical radiation to the target. Due to its high energy density, the beam causes a rapid rise in temperature on impact. This ensures that the material is melted, burnt, or vaporized with pinpoint accuracy.
The source of our laser weapon is this cabinet here. This is an industrial laser like the ones you find in a factory, where they are used to process materials. The radiation passes through the fiber here and is coupled into the beam guiding module, and is then focused onto the target using mirrors that align the laser beam using lens optics.
When we think of laser weapons, most of us immediately think of Hollywood-style science fiction films. But the images in Hollywood blockbusters have little to do with reality. This is because lasers used by the military operate in a wavelength range that is invisible to the unaided human eye. A laser used for military purposes can also inflict damage, even at great distances. This is because the laser beam spreads out like the light of the sun.
In Star Wars, you can always see the red or green or blue lasers, but our lasers in the military are mostly invisible. Whether it's a laser for cutting through something or a laser to designate a target, they are all invisible lasers. Just like this active laser system here with enough energy to easily puncture a car tire.
Especially when fighting drones, the challenge is not in the energy required by the laser, rather the small size of these flying objects. This is particularly true of the comparatively small kamikazes, but also recreational drones that are freely available and fitted with explosive devices. Swarms of them are even more dangerous.
Smaller targets like this drone actually have enough laser power to engage at relatively short distances of several hundred meters. Of course, if you want to detect such a small drone at a distance of a few kilometers and track it precisely and hit it precisely, you need good optics with the right resolution. And these systems have to be developed first. They are currently under development.
The German Navy has already carried out the first successful tests in cooperation with the industry. The laser needs no munitions, only energy. And there's plenty of it, especially on a warship. This is probably what makes the laser a weapons system of the future, but only as part of a mix of weapons, because rain and fog droplets are known to reflect light, and that ultimately deprives a laser of its power. Back in Munching at Military Technical Testing Center 61, the A400M military transporter has been in service with the German Air Force since 2014. Since then, deployment procedures have continuously been tested and approved.
The type of flying we do is a little more dangerous than what's done with troops aboard. That's simply because we don't test the procedures directly, but we test the systems that are later deployed based on fixed procedures. This also creates a set of actions that we first have to create by considering the risk. And that's the challenge.
The development and introduction of the ultra-modern transporter were partly overshadowed by bankruptcies, bad luck, and breakdowns. But the A400M has since become the Bundeswehr's high-performance Swiss Army knife. Other important tasks include dropping loads and paratroopers. An extensive team is tasked with testing the various procedures involved.
A big factor for us is the number of crew members when we're flying with 10 people. And here at the front, the two of us are busy flying. And there are things happening in the cargo hold that weren't planned or that nobody was really prepared for. Then it's very, very difficult to maintain a sense of the big picture. And that's the challenge, making sure you have an overview of the situation.
Two pilots and a loadmaster perform the maneuver in everyday squadron operations. This is because drops by the A400M can also be triggered automatically, thanks to the flight management system. But what works with cargo does not work with people, that is, with paratroopers. Before the first soldier is given permission to jump from the aircraft, dummies are used to determine whether it's safe to jump out of the side door. The technical center often gets support from the troops, in this case, from the paratroopers.
The biggest challenge is ensuring that everything runs smoothly. That's what guarantees safety. And that only works if the team's working too. That's why team spirit is very important here.
Test exercises like these can often last months. During this time, the team is constantly faced with new challenges. This is all the more so when dozens of paratroopers are waiting in the hold to jump, and everything has to run smoothly. After numerous tests, the A400M has now been fully certified by the German Air Force to drop loads of different weights from different altitudes. New parachutes are set to be tested in the near future, along with drops of special loads such as inflatable boats, vehicles, and unmanned systems such as drones. Sweden, a remote military site. The final preparations for a mega test blast are underway here. One of the largest controlled explosive detonations ever carried out in Europe is planned. 5 nations have joined forces in pursuit of a common goal.
Our concern is to provide the best possible protection in the event of such attacks. Our focus is on structural protection. This is the protection offered by infrastructural facilities and objects, structures like these here on the test site, and always thinking of how we can improve it.
The Technical Testing Center 52, located in Oberjettenberg, Bavaria, oversees the German segment of the test. This facility is home to experts specializing in explosive testing of all kinds. The engineers and technicians have spent 3 years preparing for the XXL blast. Everything has been meticulously planned and run through with computer simulations in advance. A semi packed with so-called homemade explosives simulates an attack on a military camp.
We expect extreme damage to the building structure here due to the effects of the explosion. We assume that the protective elements on the left and right will suffer very extensive damage. The same applies to this reinforced concrete safety tower. The roof structure will be gone after the blast. And the probability of survival in this test object is also expected to be very low. But that's exactly what we want, to approach the maximum load with this large-scale test, and to demonstrate all of it experimentally. These thresholds are incredibly important to us.
The effect of the explosion is enormous. What remains on the blast site is a huge field of rubble. There is nothing left to see of the truck. Instead, there's a huge crater in the ground where it once stood. Part of the protective wall has been swept away. Practically all 17 buildings that were erected on the blast site by the German expert group were more or less damaged by the blast wave and flying wreckage. In the past, numerous soldiers have been killed or injured in attacks on military camps and housing using homemade car or truck bombs, particularly in the Middle East. The purpose of the controlled demolition in Sweden is to provide German explosives experts with important data for future buildings.
Our first impressions are great. We got exactly the results we expected in advance. And you can also see it here when you walk across the test field with the extent of the damage. It's exactly what we expected.
Analyzing the recorded data and high-speed film will take many months to complete. This is not the only material used by the special testers.
This will now continue as follows. We'll now begin the complete visual recording of all the damage of all the individual buildings, and will then measure them three-dimensionally using high-resolution 3D scans.
Ultimately, the results achieved will help ensure that future buildings of the Bundeswehr at home and abroad will offer the troops the best possible protection. After all, it will probably never be possible to prevent explosive attacks completely. Technical Testing Center 91 also deals with explosions, or more precisely, blasting. So-called IEDs, or homemade explosives, were the #1 killer among NATO soldiers during the Afghanistan mission. Therefore, an unassuming hall on the grounds of the testing facility conceals a very special system, a homemade one, a so-called mine blast simulator. This is a device that simulates the impact of explosions. Engineers can use this system, the only one of its kind in the world, and developed and patented in Meppen to simulate devastating blasts. The test object is a dummy that has been fitted with the Infantry Man of the Future equipment package. The test is designed to show whether the backpack poses an increased risk of injury in the event of a vehicle explosion.
Angle sensors are installed at important positions throughout the dummy, especially in the head, in the spine, in the lower legs and thighs, even in the feet. The sensors measure in 2 axes, X and Y, so that we can then position the feet really straight. The lower legs also measure the maximum load for vertical forces. We can also reproduce this. We can see on the computer whether all the angles are really within the specified ranges.
Real blasting tests are also carried out in Meppen, but they are complicated and expensive. The simulator provides important insights without making a loud noise.
We don't have a big fireball, dust or smoke, but that's not what we're interested in. The important thing is to show how the forces that are introduced into the structure of the vehicle are reproduced here, one-to-one.
Crash test dummies, which are also standard in accident research in the automobile industry, are used for the blast test.
The dummy has various sensors installed, acceleration sensors in the head, as well as acceleration and torque sensors. That goes through the thorax, lumbar spine, down to the leg area. So we have a good 60 measurement channels here. In terms of price, the dummy is still comparatively cheap at around 70,000 euros. But once all the measurement sensors and data acquisition have been implemented, we're talking about costs of around 400,000 euros.
Not exactly inexpensive, but human lives will depend on the results of these tests.
If you look at this system, there are massive spring assemblies installed there and tensioned accordingly. A large ram is mounted on these spring assemblies. It weighs around 400 kilograms. It's accelerated upwards accordingly. And if you look at the system, the seats with the dummy system are positioned at the top. This ram then hits this seat system vertically from below. It's reproducible, with a mine detonation of the kind seen in a real incident.
Theoretically, a visitor could even stay in the hall during the test. But there's a risk that a piece of equipment could be torn off and hurled through the hall. That's why, for safety reasons, the control booth is located in an adjoining room.
On my command, 5, 4, 3, 2, 1, 0.
Well, the helmet didn't fly off. The electronic backpack is still there on the back. Nothing's come loose from the clothing system and protection system. That's very good. The next step will be to look at the measurement data and see what the loads are in the head, thorax, lumbar spine and lower leg.
Loads are recorded with the aid of extensive sensor technology and transmitted and stored in real time via data cable. The graphical results can be viewed instantly on a laptop.
We conducted an evaluation of the test. We can do this within 5 minutes. Within 5 minutes, we can make a valid statement as to whether the system is suitable for protecting the soldier or not. And what we see here now corresponds to the color code of green. So we've had a load on the soldier here that was not critical.
The equipment can then be approved for use. Not far away, on the grounds of Technical Testing Center 91, stands another unassuming hall. Here, engineers are dedicated to developing and testing the virtual battlefield of the future, designed for the advanced training of elite units and special forces.
Situation briefing. You're supporting a friendly nation experiencing an uprising by heavily armed rebels during which several soldiers were killed. The nation's army has managed to retake most of the city. Your company's mission is to clear the city, building by building.
The paratroopers are stationed in Seedorf, in the north of Germany.
You'll be deployed in this area and then proceed from there to clear the objective, following orders by the squad leader.
The paratroopers deployed have the extended basic qualification and are therefore part of the Bundeswehr's special forces. Their mission, among other things, to conduct evacuation missions and bring German civilians to safety from crisis areas. The experts at the Technology Center in Meppen are researching and developing technology in the field of virtual reality, precisely for use by such units. Much of the technology used to date comes from the civilian gaming sector. It's developing rapidly due to demand and technological progress. And this makes firefights in virtual space increasingly realistic, weapons technology included.
For the soldier, operating it is exactly the same as with the real system. We've integrated recoil. We've integrated the original magazine capacities. We've integrated the original optics and menu navigation so that the soldier can handle it just as they would the real system.
In a way, the engineers and technicians at Technical Testing Center 91 are in the process of combining existing systems from the gaming world with the requirements for military training. 96 cameras and countless trackers turn the 10 by 20 meter training area into virtual reality. Important for this, the full body sensors. The system uses these sensors to determine the position of the soldiers in the artificially created world. The core element for the soldiers is the VR headset. It generates a 360-degree panoramic virtual world, fully immersing soldiers in their training environment. The special vest and shock belt emit vibrations and electrical impulses during combat if the soldier is hit. Before the virtual battle can begin, the 4 soldiers, who can be deployed simultaneously, must first calibrate with one another. Only then can they slip into their avatar and view themselves and their comrades in the virtual world.
We don't need any real vehicles for this. We can download all of it. This saves a lot of money, and it's less damage to the environment. We can shoot here at any time, but nobody gets hurt, because it's just a virtual shot and nothing can happen.
There are currently over 20 different configurable training maps available to the troops. Ultimately, however, it will be possible to represent every conceivable mission virtually.
We have the option of using the virtual action trainer to deploy the soldiers as quickly as possible in any scenario worldwide. And we can create all the situations we need for our scenario.
The target individuals in the training scenarios are just as unpredictable as in a real deployment. They may behave passively, or they may be armed, or go on the attack.
Switch off. 2 tangos destroyed.
The participants' behavior in the respective scenarios is interactive and is currently controlled by the trainers, depending on the situation. In the future, artificial intelligence will take care of this.
After the calibration, you quickly arrive in the virtual situation, and before long you've forgotten that you are in a confined space. What's difficult is that you're missing haptic feedback in urban structures. You simply can't feel walls and doors. You have to get used to that.
During the exercise, the instructors keep a constant eye on the overall scenario and every soldier, including the orientation of the weapon and the soldier's line of sight. In a real environment, several instructors would have to monitor a single soldier in order to collect all this information accurately.
We're at the opening. Take the door on the left. Hands up! Hands up!
The feedback collected from the soldiers to date is interesting too. While some sense extra stress, for others, the virtual world is a source of less stress. The reasons for this are still being investigated in detail, so a scientifically developed training program can be created.
It adds to what we already have, and it feels good so far. As I said, you can concentrate on other things. It's a bit less stressful for me personally, and then you can improve in areas that might otherwise get overlooked.
Even complex weapon systems, such as modern guided anti-tank missiles, can be fired realistically.
Tank in the crosshairs, 2, look out, bazooka fires, move.
If the technology develops a bit more, then we can really insert the soldiers into the scenario promptly before starting an operation. And we can go through the mission virtually, as we'll experience it later in the field.
Including precise critique of the maneuvers.
That was a solid run. Let's evaluate.
This is based 100% on images, data, and facts.
Back to the top view. Cover from behind looks good. Here at the window, Danny. And you proceed.
This system contains all the data, so one can really speak of the transparent soldier. All views. Everything that the soldier has seen and experienced can be shown and presented to the soldier in the after-action review.
When they view the recordings, the soldiers often notice their mistakes on their own. Virtual training completely eliminates the subjective judgment of the trainers that normally accompanies a real exercise.
The overall evaluation is not necessarily faster or shorter, since we can evaluate many more points on the screen at the same time. Then you can go into more detail, and yes, the evaluation is definitely more precise.
This makes each individual soldier's deployment more calculable. After all, as an avatar, he can train for extremely dangerous situations at no risk to life or limb. Later on in an emergency, this training can save lives.